Yes. So, what we're gonna do now, we're not gonna use the old Win32 thread stuff. We're actually going to, we're actually gonna use the newer thread stuff. So, we're gonna be using the thread, and we're gonna use the mutex. And let's go down here. So let's get rid of the stuff we have. So event type, I think we can get rid of that. The event, I think we can get rid of all this. And then right, so okay, yeah, event thread handle, this stuff we remove. So what we're gonna have instead is a mutex lock. Yes, we're gonna have a mutex instead. So what are we doing here? So we bind the socket, we're listening on the socket, and then we're gonna have incoming requests come in. We start a separate thread. We're not gonna do that. We're gonna start listening, and then on this thread, we're just gonna continuously loop and wait for a connection. So once we get a connection, we accept, we do this. Don't think we're gonna actually close this stuff if we have an invalid socket. I think we're just gonna keep going. Yeah, I think we're just gonna keep going if we have an invalid socket. But we'll see. Okay, so next socket ID is your socket ID, and then you want to increment. Where is the next socket ID? And then create a socket, set that, sockets, put it in there. So we've established a connection. Then we're gonna go through and find the next available socket ID. So if we're at the max, then we set it back to 1. Otherwise, we increment it. And then we're gonna check if this socket ID is already in there, keep going until it's not in there, and that's your next socket ID. Then we start a new thread for that socket. So we're gonna start a new thread, that socket's gonna run on there, and then we're gonna come back and we're gonna wait for the next connection. So we're gonna accept the next connection. So we're not gonna do this bullshit. Instead, we are going to say, we're going to start a new thread, and we need to keep track of the threads because we're going to need to eventually join those threads when they're done. One thing we could do is we have the socket. The socket has, we have the thread here, so instead, we could have the only problem is that if I say thread, when you create a socket, that will create a thread, right? Yeah. I don't think there's just an empty constructor. Let's take a look here. Yeah. Constructor. Okay. So T1 is not a thread. What is it then if it's not a thread? So what is it if it's not a thread then? Waits for thread to finish execution. Permits the thread to execute independently from the thread handle. Okay, so I think okay, what I'm gonna do for now then is I'm just gonna have it as a pointer to a thread, and then if we go back here, we already have our socket. I'm gonna say socket. Oh man, I'm gonna say socket thread equals new thread, and in here I'm gonna pass in socket thread. That should start a new thread. And if we go to socket thread, yeah, this is going to change. So it's just going to be a void socket thread. Okay, and then what do we need? We need the actual, we could take the socket ID, but we might as well just pass in the socket itself. Okay, here's one thing I don't remember how to do. If we're passing in arguments, so it's calling f1, which is a function, and it takes an int, so it just passes by value, pass by reference. So I believe we could do this, a pointer to a socket, in which case we could just delete this, and then socket thread, event thread, don't need that. Okay, let's go back to the socket thread. I forgot to do this here, is that we have a socket ID. Given that socket ID, we then need to get the actual socket that we're working with, right? So socket is equal to sockets dot find. Okay, so find the socket if iterator is equal to sockets and yeah, if it's equal to sockets n, then we're gonna return, and then invalid socket ID. Okay, and then we return. Otherwise, we can then say socket. So that's that. We now have our socket. This is the socket's buffer, right? Socket buffer. Okay. Socket buffer. We don't need this anymore. Don't need this anymore. And then this is the socket's buffer. Yeah. Okay. Temporary pause. Okay. Okay. Should be that, and then socket thread. So this isn't needed. So we spawn a new thread. This is the socket thread. What do we do on this thread? We're just gonna keep receiving data. So we come in, receive data in the socket's buffer. This might be a problem if I'm using both the buffer for the reading and writing, because I could then I could receive data, and then when I'm waiting for it to handle that, I could then tell it to write. So I need two buffers. I'm gonna need buffer and then send buffer. This will actually be a receive buffer and then a send buffer. So this is the send buffer. So we receive our data in our wait a minute, hold on a second. I'm confusing myself. This buffer is the send buffer. We do a little trick here. Oh, it didn't work. Hold on a second. Or, no. Okay. There you go. Boom. Send a buffer. And then send a buffer. Send. Okay. So. Okay, so what do? We receive data. If the number of bytes is 0, then the connection has been closed, so we need to handle that. We'll handle that. This isn't an error, it's just the connection has been closed, so we'll handle that. I'll do to do. Change that color. Yeah, I need to change that. To do. On socket disconnect, right? If it's not, then it's some other error. We don't know what it is. Okay, we'll leave this for this is later. This stuff is for later. This error true thing, we don't need that. I'm not gonna have that, and I'm gonna just put this like that, and then Yeah, I don't think I need the error. So if it's 0, close the socket. Which socket? Well, it's socket. Same with this. Okay, socket. So we receive some bytes. This is the bytes. We check if socket handshake, then we've already done the handshake. If it's not, then we haven't done the handshake yet. So we call on socket handshake and we pass in the socket. We set hot socket handshake to true if that happens. Are we setting the socket handshake to yeah, handshake is false by default. So if on connect is not null, then we call on connect and we're gonna pass in the socket. That's why we need the ID. Socket ID. On socket data, so socket. Okay, hold on. We need to gain access to the mutex lock. And again, something could go wrong, so I'm gonna use yeah, I'm gonna use okay, so I could use a unique lock or I could use a lock guard. In this case, we're just going to want to lock, make the call, and then unlock. If there's any exception that occurs when handling this, I'm not sure if we should have a socket error and disconnect or we just keep going. So for now, let's just do this. So it's gonna lock, and then I'll unlock. Right. So acquire the lock, call this method, and then release the lock. Yeah. Now on socket data, okay, we get to this point here. Same thing. We acquire the lock on the mutex. And then we unlock. I have never actually debugged a multi-threaded program yet, I don't think. So this will be interesting. Okay, is there anything else I need to do? Okay. What's going on here? Socket.buffer What? What's the problem there? Cannot be initialized. Yeah, we're not sending it to the socket, we're sending it to the socket. Socket. And it's a reference. I don't get what's going on there. Why? Yeah, I don't really get what's going on there. So error, yeah, we don't have error anymore. And so if we call on socket handshake and there's something wrong, then we'll close the socket. Or if we have an error when we encounter socket data, then we close the socket, break out of the while loop because we're done, and we don't need to return anything. Yeah. Okay, so the only weird thing here is this here. I don't get what the problem is here. Socket.buffer. Is it because it's assuming that... Is it this? Is that the problem? What am I taking in? I'm taking a reference to a socket. Ah. That's the problem. Okay. Get back here. Let's just set a breakpoint there. And there was something I just thought of that I need to do. I don't remember what it is now. Oh, no, that's it. Okay, whatever we close the server, whatever we're gonna do to close it, whenever we close the server, which I'm not really sure how I don't know how we're gonna do that. But whenever we do close the server, we need to close all the threads. So I'm gonna do that. So here, once we close all the threads, we say for, I think it's this. I think you can do that. For KV and sockets, we're gonna say second, which is a socket. We're gonna wait for this socket to complete, and then once it does, we're going to delete that. Okay. That's the only memory we're allocating, I believe. Yeah, how does this work? It is second. Second's a pointer to a socket. Right. Yes. What's going on here? What? Right, it's a pointer to a socket. Oh, I have to do this. What happens when we run this? Problem with the thread. No matching overloaded function found. Oh, we don't pass it in properly. So we create a new thread here. There's the thread, and then we pass in the socket. Okay, we're running. We are running. We get a message. What's the message? Hello there. Brief pause. Yep, okay. So, where were we now? So again, the message socket ID. Okay. Okay. Connected to the server. Okay. And that's basically it. That doesn't really test anything though, because we only have one thread. We need to have multiple threads. Okay. So what we do is let's log when, so we're saying bytes, we say bytes received. We should say what thread this is on. So bytes received, the number of bytes, and then which thread we're on, the ID of the thread. So this would be socket, or the, not the thread, but the socket ID. So now if we come back here, run it. Boom. Okay, there you go. Socket, client socket connection established. Socket ID is 1. Bytes received. Bytes received. Hello there. Okay. I'm actually gonna add so socket ID, or yeah, socket ID. Okay, so now let's try multiple sockets. So we connect. There it is. So socket ID 1. Okay. Now, while we're still connected, we can open another connection here. There you go. Client socket connection, socket ID 2. So we have multiple connections. Okay. That looks pretty good. We got multiple connections. We're receiving information on multiple connections. Okay, so now what's next? We have our socket thread. This is going good. let's test sending data back. So right, so we actually want to have the connection stuff as well. So on socket connect here, client connected, socket ID. Yeah. And then here, maybe client connected, message. The actual message. This is not well done. This is not well done, but it is what it is. And then maybe on socket disconnect. I don't think I haven't implemented those yet. Okay, let's just make sure that that works. Just messages connected. Connected. Boom, message one, hello there. Yeah, client connected, okay. Yes, so we're doing good there. Now let's try sending information back to the client now. So the real test is that they should only be accessing these callbacks one at a time. So the thread will wait. Another thread is currently doing this. So we aren't accessing the same global data. At the same time. So let's say when we get a message, we send a message back. So socket send, I believe, is the method. Fenrir. Socket send, I believe, is the and it's this is the socket we're sending the information on, and then whatever that is. I'm gonna say T-Bone Burnett. Yes. T-Bone Burnett. Boom. And then when they connect. Message received. Here we have a problem. Client 2 connected. Client has closed the connection. Shit. Well, hold on a second. Socket send. This is all with the send buffer. Yes. So what's the problem here? What's the error? These are such good error messages, eh? Like, so what's happening is okay, what's happening is this is the handshake. this is the handshake call, and then the handshake is successful. We call client connected on socket 2, and then when it goes to send information, is that when the client's closing the connection? Is that what's happening? If I refresh it, okay, the application is kind of frozen. Shit. Okay. So what's going on here? What's going on here? Okay, so we connect. No. Okay, so we're on this main thread. This is the main thread, and we're accepting connections. Oh, I think I know what the problem is. So we got 0 bytes back from the client. So client has closed the connection. And so we close this socket and then break out of this while loop. So the thread is now dead. Man, yeah, there's still quite a bit we need to handle here because well, one problem is that okay, let's breakpoint and see what's actually happening here. Let's see what's actually happening here. If there's an error here, if there's any kind of problem here, that lock will be, well, this won't unlock. I just don't think there's a point in having a lock guard because I guess it will go out of scope. Okay, let's try it. Let's see what's actually happening. So, when the handshake is made, right? That's good to go. And then right. Okay. So let's set a breakpoint every time we receive data here. So good to go, right? We connect, we get the message, good to go. Why is it that when another person tries to connect, there's a problem? Bytes received. That's our handshake. Handshake is successful. Right? Connected to server. Good to go. Okay, acquire the lock. Unlock it. Okay, it got the handshake. It should now send the message. We get 19 bytes. No, I think that's right. We get 19 bytes. We already have a handshake. So now we look at okay, that's good. Hello there. We have a message. Acquire the lock. Call this method. I think the problem, because things were working before, right? The problem is that we're sending data now. Right? That lock is still held. We're now sending this data. This should be socket 2. It is. Okay, so the socket send buffer is T-Bone Burnett. But yeah. Oh, okay. It got the information, T-Bone Burnett. Right? Now we break out of here. Unlock. So where are things failing? Return. We're good. So everything's good. We're good to go. Both clients are good. Everything happened. Everything's good. Now nothing should happen anymore. Everything is good, right? Everything is good. So this is telling me now, let's test this again. Shit. What's going on now here? So I can connect multiple times and we have all these different client sockets. Okay. Now it's working. See, now it failed there. Client has closed the connection. See, why did that happen? Okay, we didn't get connected, and so because we didn't get connected, I think the handshake failed. So this is actually an error. So on the handshake, client connected, and then error. Oh, here we go. There's errors here. Okay, here we go. Failed to receive client socket data. Oh, what is this here? What's this message? 2 bytes. No. What? Okay. It's always 2 bytes, right? The error is always these exact same 2 bytes. This is making me wonder, right? Connected to client 11, we then receive this message, right? Then we receive 8 bytes from client 11. And the message is that. I'm curious what that is. Is it pinging me or is it sending me some kind of opcode? So actually going back up here, yeah, we have the opcode here, right? We have the op code, but we never use it. Right? We don't do anything with the op code. This is when we're sending data. When we receive data, we don't do anything with the op code. I'm gonna... Oh, what the fuck is this? Yeah, okay. I'm going to not only... I'm just gonna... I'm just going to... I'm just gonna print the op code. It's on the handshake. It's failing on the handshake, right? We receive the handshake packet and we're failing there. Client closes the connection. Error, we don't know why. Yeah, right. So connection to this failed. So it's on it fails the handshake. Let's see if I can reproduce it every single time. Yeah, see, now it didn't happen. But we're still getting this error. The opcode is a smiley face. Is this a synchronization issue? Is this something else that's happening? That's what I need to figure out here. The handshake is failing. Right? Here's another thing is that we're connected to client 1. Yeah, let's get rid of the opcode thing. We're connected, right? Good to go. If I refresh this one again, so what's happening? Client 1, okay. And then client socket connection established. Socket 2. Right, we've now connected to socket 2. When I refresh the... Okay, so refreshing the page fucks it up because... I think it might be because it's not disconnecting, right? We receive 8 bytes from socket 1. It should be a new client connection, and it's not. We receive 8 bytes from socket... Oh, no. Okay, we receive 8 bytes from socket 1, and the message is this. And we don't understand it. And then the client reconnect. Okay, so this thing I think we can figure it out. I think we need to start handling the socket disconnection. Okay, so we accept the connection to the socket. That's good. And then we have our callbacks. We can handle a message. We can send a message. Now we need to be able to handle errors and disconnections. So what happens when we send this message? That's the closing socket message, I think. So the close frame contains an opcode of 8. So let's do this. Let's put a breakpoint right here. Boom. Let's run it. All right, should be good to go. Yeah, we're good to go. Again, should be good to go. Yep, we're good to go. And now, now we're gonna refresh. What's our opcode? 8. Yeah. That's saying it's a disconnection, but we're not handling that that way. We're handling it as an actual message, and that's why there's that error. So let's fix this first. So, opcode of 8. The close frame may contain a body that indicates a reason for closing. I don't care if it closes, we close. I don't care what the reason is. I could log it, I suppose. Such as an endpoint shutting down, an endpoint having received a frame too large, or an endpoint having received a frame that does not conform to the format. If there is a body, the first 2 bytes of the body must be a 2-byte unsigned integer in network byte order, representing a status code with a value code defined in section 7.4. So these are the closure codes. I don't think I'm gonna care about this. If it closes, it closed. This data is not necessarily human readable, but may be useful for debugging or passing. The following 2-byte integer. Following 2-byte integer, the body may contain UTF-8 encoded data with value reason. Is not defined by this specification. Okay. Close frame sent from client to server must be masked. Okay. The application must not send any more data frames after sending a close frame. Okay. Must not send any more data frames after sending a close frame. If an endpoint receives a close frame and did not previously send a close frame, the endpoint must send a close frame in response. When sending a close frame in response, the endpoint typically echoes the status code it received. Fuck, I think we do need to get that status code. It should do so as soon as practical. An endpoint may delay sending a close frame until the current message is sent. For instance, if the majority of the fragmented message is already sent, an endpoint may send the remaining fragments before sending a close frame. However, there is no guarantee that the endpoint that has already sent a close frame will continue to process data. Okay, let's go back to here. To close a connection, either the client or server can send a control frame with data containing a specified control sequence to begin the closing handshake. Detail in 5.5.1, which is exactly what I was reading. Okay. Upon receiving such a frame, the other peer sends a close frame in response. The first peer then closes the connection. Any further data received after closing the connection is then discarded. Okay. So what is a close frame? Well, the close frame contains an opcode of 08. May contain a body that indicates a reason for closing. If there is a body, the first 2 bytes of the body must be a 2-byte unsigned integer. I'm not going to include a body, and we'll see what happens with that. After both sending and receiving a closed message, an endpoint considers the WebSocket connection closed and must close the underlying TCP connection. The server must close the underlying TCP connection immediately. The client should wait for the server to close the connection. Oh, that's not what it says in there. The server must close the underlying TCP connection immediately. The client should wait for the server to close the connection, but may close the connection at any time after sending and receiving a closed message, if it has not received a TCP close from the server in a reasonable time period. Okay. Okay. So let's deal with this. So on socket data, so we get some socket data. What do? Well, if we get an opcode of 08, then we know it's not a message. So we're not even gonna bother doing this stuff. So if the opcode is equal to this, close frame. And we're gonna want to respond, right? Right, we're gonna want to respond. Yeah. But here's the thing, how do we respond? We don't want to send a message, right? We don't want to send a message. So what do you put? You put the opcode in. We put 80, that means it's text. Or no, the opcode is 1, meaning that it's text. So we put this, and then we put the opcode, which is 1. Is that what we're doing here? I think so. I'm not going to put a message at all. So we could just do a message size of 0. And then do a mem copy. Okay, I think what we should do here is this. So socket send, socket, and then the message. I think we should include the opcode here. Maybe not. Maybe we don't even need an opcode. I don't know. Yeah, let's do it. Let's put an opcode. So socket send, the socket, the opcode, and then the message. Yeah. Socket send. So the opcode's omitted. The only difference here is the opcode. Message size will be 0, so we don't have to. Yeah. Well, the thing is, so the thing is that we already have the socket. So on socket data, I think we'll have send socket data, and we can just pass in the socket, right? So send socket data, the socket, and in this case, an opcode, just an opcode. Close frame, so send socket data. So send socket. This is always going to be just a message, so I don't want to have to deal with opcodes here. Socket send. instead of socket send, I think we would say yeah, I think it would be send message. Send message. And what send message will do is if everything we do here, but what we do here, I guess we could say static here just to indicate that it's not meant to be used directly. I guess it doesn't matter. Well, I'm still gonna do it. Send message, so send socket data, the socket, the opcode, and then the message. And what we're gonna do what we're gonna do is this, right? Here we have to find the socket. Once we get the socket, there it is, right? And then we can do this, which is send socket data. The socket, and then we could maybe we can just do this. The opcode is just 0x1, which is text, and then we pass in the message, right? So send message, boom, send socket data. That's the opcode, that's the message. Here we do this. I'm just gonna do a check. If the message is empty, then we're not gonna bother doing this, right? The message is empty, don't bother mem copying the message into the buffer. There's no message. Then we're gonna send, it's not gonna be, so this is different, it's not, so it's just a dot. Socket send buffer. Here we go. Boom. Can I just do this? What happens if I do that? Socket send buffer, right? What do? We pass in the size, right, of the message. Okay, hopefully this will work. Hopefully this is good. Okay. So socket send data. Send socket data. Yes. So that's that. This is the more generic method now. And then we say send message. So that's great. And then if we come back up here, we say send socket data. Maybe I'll add a constant for that. Yeah, maybe I'll just add a constant. opcode close. And then there's opcode text, right? Opcode close. So we just send a packet with the opcode of close, right? And then opcode text. Okay. Oh, but then there's the other issue is I don't want to send data here. So data should be... Yeah, the message is only when we actually send a message, right? So, I think, hopefully. So, I think we should move this back in and send socket data should just be an opcode, right? So, you do this. Right. So this has to be done for this. Instead of opcode here, we can say opcode text. So when we send a message, this is what we do, right? Yeah. We send a message, this is what we do. If we're just sending something that's just an opcode, we do this. We don't need a buffer index because the buffer index is always going to be 2, right? We just set the opcode. The message size is 0. What's going on here? Right? This is the size of the message. The size of the message is 0. Send buffer. It's the buffer index, which is 2 plus 0, which is just 2. Right? Failed to send socket data. Send socket data, that's not good. This has to go back to how it was before. Yeah. We don't actually have the socket here, so we have to say socket. Technically, it could be a reference. Technically, it could be a reference. Yeah, I don't know. What's this? Shift S? No. No, it's not. I'll just delete this and then I'll do this. Okay. Oh. Oh, what did I do? I just replaced it with the dot. And then let's go to main. And this should change. It should be send message, the socket, and then that. What does this do? This should now handle a close frame. So we get a close frame. If we receive a close frame, then so we're connected. We're connected. If we receive a close frame, yes, we receive a close frame. We should then send a close frame back, which it does. I guess it doesn't really do anything at this point. So one connected, two connected, and then one we received 8 bytes, which was telling us that it's disconnecting, right? Failed to retrieve client socket data. Why is it saying that it failed to retrieve socket data? Everything seemed to have worked fine here, right? See, so this error is something else. It goes to establish the handshake and it can't. Why is that? The client closed the connection. Failed to retrieve client socket data. Where is that? By the way, where is that? I'm recording. Where is that, by the way? Okay, if the number of bytes is negative, then okay, so wait a minute. Let's go through that scenario again. So, yeah, see, it goes to connect and it can't. I wish I could find out what this problem is. Is it because Yeah, what's the problem? Like, we receive a handshake. I'm assuming the handshake we're sending back is correct. And then the client closes the connection. And we don't know why. And then it did it a bunch of times and now it works. That's very strange. Is it because I'm not closing the socket on the server side? Is that why? And so that socket is still open? I'm not sure. I'm not sure what the problem, but I'm not handling all the error cases. And that's really what we need to do now. Okay, so what's actually happening here? So it's actually happening. We get a packet that's close. Okay, so it told us we need to close, so we send back socket data of close. We tell the client to close. So we received a close, we sent a close. Once we do that, we now close the socket connection, right? So we need to do that. We need to close the socket now. The problem on socket data. The problem is this. Let's say while you're doing this, you then had this socket, you wanted to send data out on this socket. It would just go and send it off. I think when we receive data from a socket, we should lock. I think each socket should have its own lock as well. And that's that when you receive data, you lock it so that nothing else can happen. So if you go to send data, it will wait. And then once, if it's a close frame, then you close, you send the close frame, and then you actually disconnect. You can then say the socket's done, and then when it requires the lock before it sends the data, it will check, is the socket done? Oh, it's done. It just don't do anything, right? Because we're just locking on the callback functions. We're not locking on the actual socket. So we can get this send socket data frame, and then at the same time we want to send data out on this socket, we send the close response, we close the socket, and then he sends the data on the socket. Yeah. I think what we need to do, when we're just here waiting, we don't do anything, right? Once we get a response from receive, so once the socket has received something here, I think we should acquire the lock for this particular socket. So you can't do anything with this socket now because he's just received data. You can't send data out. Problem with that. The problem is that, let's say a socket receives data, goes to the callback wants to send data to this socket. Yeah, that's not gonna work because you're gonna get locking there. Shit. Now I think what you do is, so you received data, you lock the socket. So we would say socket lock dot socket mutex lock, right? So we would lock this socket's mutex, Again, I may replace this with a lock guard. We'll see. We lock, or a unique lock. We lock the sockets. We lock the mutex. And then if the number of bytes we received is greater than 0, yes, then we come in. Okay, we do the handshake. Let's say we already did the handshake. Then we come in here and we call on socket data. Now, this may be a close frame. If it's a close frame, we're going to close this thing. So if on socket data returns false, we are going to close the socket. And then we're going to break out of the while loop. We're done. Now, if we do this, we close the socket. Once we close the socket, we're going to need to mark that socket as being closed. And we're going to want to delete it from the pool there. So we're going to close the socket. Then we're going to say socket ID. We're going to set that to be null, which is 0, because the socket ID can never be null. We're going to set the socket ID to be null to indicate that to indicate to anyone trying to use the socket that the socket's already been closed. We close the socket, set the socket ID to null, and then we would say unlock the mutex. So if the other guy was trying to send data, he'll now gain access to the lock, and then he'll check, is the socket ID null? Oh, the socket's already been closed. Don't do anything. Right? Otherwise, it's not. It will start sending data out. Boom, and then it will release the lock. And because I'm doing this, really, we can go back to the sockets having one buffer, because we're locked whenever we are. If we're gonna write out to the buffer. We need to acquire the lock. No, we can't do that. So we wait once we receive data, lock. We close the socket, set the socket ID to null, unlock the mutex, and then yeah, we're done with that. Breakout, we're done. If we don't have a handshake yet, on socket handshake, if we're good, then we've done the handshake. I don't have a case where this is not good. If on socket handshake is false, then something has gone wrong. Right? Yeah, something has gone wrong. There's actually an else here that I haven't implemented yet. Okay. So unlock the mutex. If we don't already have a handshake, there's no point of locking the mutex, right? If we already have a handshake, we yeah, I guess we'll wait till the handshake is done. Okay, handshake is set to true, so it's sent out the handshake. Handshake is set to true, and then wait until we say unconnect. Well, unconnect could do some other stuff. So I think, yep, socket, mutex, unlock. Unlock the mutex here. If there's a problem with the handshake, then Okay, well, when it wants to close, it's going to send us the close thing, and then we then respond with the close thing, and then we close our socket. And then we close our socket. Instead of saying socket ID is null, I think we should just delete the socket from the so we would actually delete the socket here. Okay, let's just focus on what I was doing here with the close. It sends us a close, we send it a close, we close. Would we ever close the connection? I suppose yes, but that's a different story. If it's going to send us a close, we should never receive this. If ever we receive number byte 0, the connection is closed unexpectedly, I guess. And in that case, there's nothing for us to do. The connection's already closed, so we close the socket. I think what we should be doing here is, in this case, right, if socket that is handled correctly, then we just continue. We just loop and continue. There's nothing else to be done. All right, if the socket that is handled, we say, we unlock the lock, and then we just say, yeah, we're done. And then this can move down to here. Right, close the socket. This, instead of setting the ID, what we really want to do is delete it from the map. And then we unlock the mutex. Right. If it's good, unlock and then continue. Right, good to go. If we don't have handshake, on handshake, if it's good, handshake is true, unlock the mutex. Don't need to lock it anymore, and then acquire lock to call the callback. Right. And then we're done. Right. We're done. So if there's a problem here, or if there's a problem here, then we'll break out and we'll close the socket connection. All right, we'll break out, we'll close the socket connection. If the number of bytes is 0, then client has closed the connection. So if that's good, then we continue. If that's good, we continue. Otherwise, we're gonna break out. If the number of bytes is 0, client is equal to the connection or failed to receive data. Some kind of weird thing happened. Close the socket, boom, and unlock that mutex lock. Okay. Now let's go back to on socket data. On socket data, if it's a close frame, then we should actually be returning false. False because false will have us break out of here. We'll close the socket and that'll be the end of the day, right? So we return false, meaning we've closed the socket. Okay. So we receive the close frame, we send the close frame, and because we've now disconnected, we should actually we should notify whenever we've closed the socket. So we close the socket, we've closed the socket. You won't be able to send because, okay, here's the danger. We've got the mutex lock, right? On that socket. We send the close message, and yeah, brief pause. Okay, so where was I here? Yeah, how are we gonna send on disconnect? Here's the problem. If I send a disconnect message, that means the socket has now closed, and so you can't send any more messages. So we don't have wraparound. The IDs keep increasing, so that should never be. A socket with a given ID shouldn't be revisited for a long time, if ever. So what we do is we close the socket. We actually close the socket. I'm just doing this for now, but I'll remove it from the map, and we need to unlock the mutex as well. May I use a unique pointer to do this? Oh no, I don't think I would create a unique pointer. It's just, if we call the callback, and let's say the callback wants to do some stuff, that's fine. But if the callback tries to send data on that same socket, what's going to happen? Well, we have the mutex lock on that socket, so we can't do anything with it. Well, we shouldn't have the mutex lock anymore because we've closed the connection, we've deleted it, we've unlocked it. That socket is now gone. So we can now say, hey, the socket is disconnected. If you try to send information on this socket now, it's not going to be there. So forget about the lock. The socket won't even be there. I think that's right. If is it server description dot on disconnect? If that's not null, is that right? Server description on disconnect. we need to know which socket it was. What is the socket ID? It's a socket ID, right? So I can pass in that. Okay. So now we should get our disconnect message, but before we do this, we have to say we have to acquire the lock, and then we unlock. No, I'm not going to use the mutex for long. This is just temporary. So on disconnect, we handle it this way, either from this or if we did a proper disconnection handshake. When would an error occur? Well, this would be some weird error. If this happened, there'd be some weird error. So I would say disconnect is false, and well, on disconnect, well, no, we always say this on disconnect, right? We've disconnected. On error, do we care? Are we gonna handle on error? An error happens, we disconnect. An error happens, we disconnect. So I don't think we actually need on error. Do we have on error? Yeah, I don't think we should have socket. What do I care about? I want to know when I've connected, when a socket is connected, when we received a message from a socket, and when we've disconnected from that socket. If that socket suddenly disconnects, then I want to know that. When we've disconnected from that socket. If an error occurs, we should just disconnect. And I don't think I'm going to handle that. So I don't think we're going to need this. Right? I don't think we're going to need that. On socket error, don't think we need that. On socket error. Yeah, don't think we need that. We want to know when we disconnect, and that's basically it. I'm going to go back to main here. So client disconnected. Okay. So client disconnected, the socket ID okay, we need to add I didn't add the mutex for this socket. So now the socket has a mutex, and then send message will need to lock, right? We first find the socket, and if we find a socket, okay, there it is. We need to lock before we do anything, right? Because we don't want to send any data. And if the socket, well, okay, at this point we would have to then check. We would have to then check Is the socket... Well, we're actually going to delete it from the map. So here we'd see that, okay, it's not in the map, so failed, and it just won't do anything. But, okay, if we do have the socket, then we need to acquire the lock. So socket mutex.lock. We're going to lock this thing because we're going to send data, right? And then whether we succeed or not, we unlock the mutex. This still isn't going to fix the problem, though. We actually have another problem, and I don't know what it is, where for some reason it sends us a handshake and it just fails. What's the problem here? Oh, that's the problem. Server description. And this isn't a pointer. Okay, so we're running. No. Hold on a second. Let's try that again. So, client-side connection established. We receive the handshake. We're connected. They send us hello there. We're sending back. We're trying to send back some information, and it fails. What's the exception here? What's the exception here? What? What's the error? Opcode text is correct, right? Yeah. So if we send a message, that's the error. It doesn't work now. What did I fuck up? I love the information that Visual Studio gives you, eh? Look at this, it's so great. Triggered a breakpoint. Wait a minute. Reconnect. Oh, right. That's the failure. I think the socket is null. And the socket is not null. But the mutex is failing. Why is the mutex failing? The mutex is fine, but when I lock, we get an exception. Okay, what's weird is that when we receive socket data, we would have locked. Right? And that's fine. Yeah, it works fine. So on connect, okay, we unlock. We get more data. Fine, let's close the connection. So we have a message. We have a message. Right, here's the double lock where you're fucked because we say send message. Send message. Oh, right. It will try to acquire the lock and it fails. How come it fails? It doesn't just wait? So yeah, we get data on socket data. That's great. Once we have the message and everything, really, once we know it's not a close frame, we can release the lock on the socket because what else are we doing? We're reading the message in. But we can release the lock on it, and then we can then do the callback. We only need the lock because we want to make sure that something doesn't happen. We've received data. We come in here. We know we didn't receive the close frame, so we're not doing that. So I think we can just, at this point, I think we can just unlock, right? Yeah, I think we can just unlock. Just unlock at this point. So if everything works, well, if everything works, it's already unlocked. If there's an error, then okay. There you go. Now it works. Okay. Two problems. One, we're still having that issue where when we initiate the handshake, for some reason, the client closes the connection on us. I'm assuming it's closing the connection because it's not seeing something that it expects. Is that because our handshake is wrong? It's just hard to tell because I can't see what handshake I sent and what they, I don't know what they sent us. So that might be tricky to debug. But we have one guy, then we have another guy, met client 2. If we do this, what does that do? So client disconnected. So 1 disconnected, that's correct. And then 3 connected. And here's the message. Right. Okay. Now if I just close a connection, let's see what happens if I just close it. If I just close it, we get client 3 disconnected. Okay. client 3 disconnected. Okay. So we've got that weird bug where for some reason when we go to connect, it just doesn't work. This one, and I can't reproduce it exactly. It just seems to happen randomly. Bytes received, client connected, client has closed the connection, client disconnected. I'd have to see what we received in terms of the bytes and what we sent back. Is it that we're not sending back the right message? Is that the problem? Or... Man, like fucking... Of course, like... This is what I don't like about JavaScript libraries. They give you no information. They give you no... It's either cryptic, like React's errors are always the most cryptic thing ever written, or just nothing. WebSocket connection to this failed. Colon, nothing. I don't think it's a problem with the handshake, because I think when I was initially doing the handshake, it was actually saying that the handshake was wrong or something, or the header of the frame was wrong. It used to say that, now it's not. So problem, and then the error event, again, useless information. This tells me nothing. Look at all that, nothing. Yep. Unless there's a way to get error information out that I don't know of. That could be one thing. Try to get more error information. Otherwise, I have to guess why the connection failed, because then if I try again, it works. If I try again, it fails. Is it? I'm wondering if it's something with the server. Like we see client 7 disconnected and then client 8 connected, and then the client closed the connection randomly. But if we did successfully connect, we would actually get a message saying that we've connected to the server. Yeah. So at this point, what do we have here? What we have is we have multiple threads. We can successfully connect multiple sockets at a time, multiple clients at a time to the server. We've got some basics of the locking, but I think I need to improve this. I don't want to just have mutex lock, because if an error happens, then the whole thing is fucked. We can handle multiple connections. When a connection's closed, we're gracefully handling that now, and we're getting our on disconnect message. That's good. So things I need to do now, figure out what this bug is where it can't connect. The client randomly just can't connect. So there's that. Make sure that my locks don't ever run into a situation where there's going to be a problem. And then another thing is that I need the threads to, like the threads end here, right? If we close the connection, the thread just ends here, right? Is that okay, or do I then have to do a thread join? A thread join will wait for the thread to end, but if the thread already has finished, then I don't need to do anything, do I? I don't think I do. I don't think I do. I don't need to join it because it's already closed. It's already finished. I'm only going to have to close the threads that are still active. So all the threads that are closed, we're going to delete the socket, free everything, free all the data. That thread's now gone and it's done, right? I think. It's just when the server shuts down, if there are threads still actively going, that we're going to have to call join to terminate them. I'm going to have to look into that though. Let's actually take a look at that. Which requires the join. Fuck. In theory, the thread destructor could have called join instead of throwing an exception, but that subjectively may increase the risk of deadlock. So the thread terminates, like the thread method terminates, but the thread will still be there until you call join. That's a problem because that's a problem. Yeah, that's a problem. Okay, and that means that the thread resources can't be cleaned up until the ref count drops to 0. Right. Okay. What does it mean to be destructed, though? I think they mean actually destroyed, not the... Yeah, one problem that I've got here. Okay, so we're making some headway here. I mean, we have a server that runs, and we can have multiple connections made. Right. Notice you get the same error. Right? You get the same error here if the header response is wrong, you get the same error. Actually, I'm gonna do a little experiment here. If I go to a handshake on socket handshake, if we do this instead, like if I say set the status code to be 102, for example, hopefully it will fail. Handshake. Yeah, it fails. So if the handshake is wrong, yeah, it doesn't give. It's just weird. It doesn't give you the information of why it failed. Here's the big thing: WebSocket detailed error info. Data. Yeah. Okay. So data. Is that right? So I think that's what it is. I think the handshake is failing for some reason. Sometimes. Only sometimes. Only sometimes. Undefined. That's useless. Oh, it doesn't actually send these. Right, those are those error codes we're looking at. Normal closure. Oh, well, if we can just get the code, can I just see the code? No. Yeah, this is what I hate about JavaScript libraries. They give you no information. They're never well designed. I mean, this is crucial to have a good library. Is when you have errors, it actually gives you meaningful information. Just tell me something. Just give me a little sentence. Just give me some hint. Instead, this is what you get. Failed. Connection failed. Error. Nothing. Listen on the close event. It has a code. Socket closed. Here you go, 1006. I'm not even gonna put the error because there's no point. It's basically useless information. So 1006, and I can actually refer to this guy here. 1006. As defined in section in a closed control frame may contain a status code indicating read for closure. Closing of the WebSocket connection may be initiated by either endpoint, potentially simultaneously. The WebSocket connection close code is defined as the status code contained in the first closed control frame received by the application implementing this protocol. If this closed control frame contains no status code, the WebSocket connection close code is considered to be 1005. If the WebSocket connection is closed and no closed control frame was received by the endpoint, such as could occur if the underlying transport connection is lost, right? The WebSocket connection close code is considered to be 1006. Must not be set as a status code in a closed control frame by an endpoint. It is designated for use in applications expecting a status code to indicate that the connection was closed. Abnormally, without sending or receiving a closed control frame. Is it because it's sending us the 1005 and I'm not sending it back, and so it sees it as, and then I close the connection so it sees it as an abnormal closure? But having said all that, this happens when I connect, not when I disconnect. And it doesn't send us any information, it just closes the socket. Wait a minute. We try to connect on error. We just log the error, then I close the socket. I think the socket's already closed at this point. So we try to connect. There's an error, so we log the error, and then we close the socket. I think that's why we're getting that code. I think it's because of that. I don't think it's actually. No. It's not. So connection to that failed. An error occurred, and then the socket closed 1006. The weird thing is 1006 should be that it just disconnected, but then on the server side, the server just got client has closed the connection. So it sent us 0 bytes. How am I failing to release the lock? We lock. We unlock here, or we unlock. Oh, right. We don't unlock here. But then we unlock here. When you get here, we unlock. We will always unlock when we get to here. Well, you can't tell because, right. Yeah. Okay, let's see what's happening here. So we get our bytes, we get our handshake. That looks good. And then next time we get 0 bytes. The only thing I can think of is that the server is sending back a handshake that's not valid. Well, in this case it is not valid because I've purposely set this to 102. If I change this back to 101, okay, so that implies, right? That implies that when this happens, this is likely a problem with the handshake. Maybe there's a bug in my handshake code. To see that, I'd have to see what was the request and what did we respond with. Yeah, so here we get a status of 101. So yeah, I think it's again a problem with the response that I give. So it connected, okay, 101. Now not 101, but I can't see the response. I think what I need to do is start looking at the packets with what's it called, packet shark or whatever, so that I can see the packets themselves to see what I'm sending back. I think I know what the bug is. I think it's with the handshake, so we need to sort that out. Apart from that, we can have multiple sockets connected to the server simultaneously, so that's good. Right. Right, we can have multiple sockets connected and we can send information back, so that's good. I'm just going to do a little test. I'm going to do simultaneous sending of data. So, I'm going to do this. No, this here. I'm not going to send this just to this guy. I'm going to say, I'm going to try to send it to socket 2. T1 Burnett. So it shouldn't work if once that's because that socket's not going to be there. So it's going to send information to 2 sockets, right? So it connects and we should get an error. Yeah, because that socket doesn't exist yet. Then with this guy, we get that message and that message. He doesn't get anything, right? Okay, so that's essentially by kind of broadcasting. We can send a message to 2. So the basics are there. We need to fix that handshake bug. Need to figure out what's going on with that. I may look into that bug offline because it might take a while to track that down. I'm sure it's something small because it's working most of the time. I'm gonna need to look at the packets, I think, to see exactly what the problem is. Why that handshake is being rejected. So we gotta fix this bug. What's left? Well, the basics of multi-threading are there. That was my goal today, was just to have sockets being able to, more than one client be able to connect to the server, and that's what we have now. I'm wondering if I should wait for the next video for this, or continue the work now. So what's next really is I want to kind of clean up this stuff with the locks. I don't want to just use mutexes like that. We need to kind of make that safer. We gotta fix that bug, and then I'm just trying to think what else I need to do with the multi-threading. Oh, okay, yeah. We need to be able to actually handle like joining the sockets once they're done. So once the socket is done, closed, we need to be able to handle that. And then, yeah, that's our main problem. When we close a socket, we end the thread, we need to be able to join that back to the main thread properly. Okay. Which is here, right? This is our main thread here. The problem is that accept is a blocking call. So how can I just join the thread if I'm stuck in this blocking call? That's one issue. Yeah, how do I deal with that? So those are the 2 issues I've got right now. That handshake bug, and then how do we actually properly join these threads to free the resources? How do we do that when a client disconnects, the socket is closed, the thread terminates? How do we properly join that back in? That's what we need to do here. Brief pause. Okay, I'm back. So let's get to the bottom of this. Let's open up Wireshark. This guy here, let's run the application. And then what we're gonna do is start capturing. Okay, stop there. So these were all successful, and this last one was not. So why wasn't this last one successful? This is the key that we sent in. Right? This was the key that we sent in. Yeah, this is the key that we sent in, and then this is the magic string that we append. So this is the hash. Now, if we say base 64 from hex, we get this value here. Now, let's take a look at what that is compared to what we passed in. This is what we passed in. This is what the response was. We said this is the response here. This is way off. Why is it way off? XSY is what it passed in. XSY. Yeah, that's right. This is what it passed in. Hold on a second. No, that's right. That is the key. And then okay, so there's the problem. We're not passing back the right thing. Why is this way off? Why is this way off? I don't know. This is way off. This isn't even close to being correct. Hold on a second. Am I... Okay. Like, it's not even close. Okay, let's do a check here. So let's pass this in, which is what the request was. Okay. Yeah, this is what the request was. Let's try doing this. So, let's say let's do this. So let's say, let's force it to be this, and let's see what happens. Let's see what happens with the hash and everything. Because this is way off. It's not even close. Okay, so the hash we generated was EA. So the hash is wrong. So it's not the base 64 encoding, it's the hash. Wait, is this right? This doesn't make any sense to me. Did I copy that? No, I didn't. Okay. I didn't copy that right. There's a 1 at the end. There we go. And if you take this and we convert this, we get, aha, okay, we get this, which is a lot closer to what we have here. Now if we say boom, these are, sorry, you can't see this. Okay, so we can see this is exactly the same up until we get to here. Here, we get a bit different. Why is that? Okay, let's go back to here. So our hash is it the hashing or is it the base 64 stuff? So this is off, but is it the hash that's wrong, right? Is it this that's wrong or that? So let's look at the actual hash. So this is what we should have, this is what we expect, and then this is what we actually get from the hash. Ah, okay, so the reason why the base 64 encoding is off is because the hash is wrong. The hash is identical up until here. Okay, I think I know what's going on. So the hash is actually correct, but we're missing a 0, and I think that's because that's a prefixing 0. So this hash, remember, is 5 32-bit integers. Each one is going to be an int value. Each one is going to be an int value. Right? This is what we do at the end here, right? We have our 5 like where is H? What is H? That's not good. What is H? H is an unsigned int, I believe. Yes. It's a uint32. So it's a 32-bit integer. I don't know what the maximum value is, but yeah, I don't know what the maximum value is, but so 2, 3, 4. So that's 1 byte. 2, 3, 4. That's another. Wait, 1, 2, 3, 4. 1, 2, 3, 4. Right. I'll look at this one. So this is 1 byte. This is the next byte. This is the next byte. 2. Right. So you can see it here, what's going on, right? No. You can see here what's going on, right? We have 5 bytes. I did a 32-bit integer, but I think these are actually just bytes. Like they might be, that's the thing. I don't know if these are going to be more than a byte or what. But we see what the problem is here. The problem is that it's not prefixing this one with a 0, which is still valid. Like these numbers are the same in hex. It's just this one has the 0 and this one doesn't. So we need to add a 0. So that's the bug. The bug is that it's not prefixing with the 0. How do you do that? Oh, okay. So you should be able to do this. So it will add zeros there. But this is an IO man IP. IO man IP. So we say fill. Is that right? Fill with zeros, yeah. And then we say set W. Okay, so then we have hex. Set W. The width is 8. And then we just copy that. Right? Is that right? I think that's right. So we fill it with zeros. We're doing hex, and then it should be 8. But that's the thing I'm not sure of. Could it be more than 8? Right? Could it be more than 8? I'm not sure. I don't think it will be. I don't think it will be. Now let's try that again. Oh, right. IO man IP. There's that. Boom. We got our 0 there, right? We got our missing 0. Okay, so if this really works, then I'm gonna remove the breakpoint. We're gonna kill this, and if this really works, then so I'm gonna remove that. We'll run the application. We were seeing that this would fail every, like within 10 tries, it would fail at least once. I think we fucking fixed it. I think we fixed it. Boom. Okay. So that weird, bizarre handshake bug is finally fixed. That's actually a bug in my SHA1 code. I'll have to go back and fix that in the SHA1 repo. Yeah, we're good to go. We're good to go. Let's have a second tab. So we don't need these guys. Boom. Yeah, we are connecting now without errors. That bug's been around for a while. I've always had these handshakes that failed. I couldn't figure out why. Boom. We're good. We are good. I haven't used Wireshark. Actually, I don't think I've ever used it. I've had it for a while, but I don't think I ever used it. Back in university, I had it and never used it. Yeah. Debugging with Wireshark. Boom. So, that looks like it's good to go. I'll have to make the same bug fix. I'll have to make the same bug fix in the repo. This fix here. Very simple. I'll have to do that in the repo, so I won't have to remember to do that. Should be good to go though. Could just do that in a for loop, I suppose. Oh, one thing I wanted to do was those magic numbers. So, where is that? Yeah, this is a small thing, but I rather have it in lowercase. So EAFA E D A C A C A B D C B. I think that's right. Only other thing I could do is I could do this in a for loop. Technically, I mean, I could do this in a for loop. Yeah, it's fine. Let's just make sure we're still good to go. No, I made a mistake. I made a mistake. What was the mistake? EAFA EDACA CABDC. What's the mistake? Oh, like you literally have to append it with that. Oh, right. This isn't hex. This is actually a string. But what I want to actually do here is I actually want to take this out, and this should be a what's it called? Magic. What do they call this thing? It's a magic string. Okay. Magic string. So go back here plus the magic. Little bit of just a little bit of organization there. Yep. You can have 2 clients at the same time. Okay. Okay, so we fixed that handshake bug. Now what? Now we need to deal with the fact that when we close a socket, so we get to this point, we close the socket, we set the socket ID to null, and then we unlock the socket, meaning that other people can now use this. We can now send information and whatnot. So we unlock the socket. This is gonna get complicated really fast because I think I'm gonna have to have a lock on the sockets map if we're gonna be deleting sockets. Here's a crazy notion. What if we don't delete sockets? Right? What if we just reuse the sockets? So so where are the sockets? Opcode. So we have our sockets here, right? What if we don't delete the sockets, we just reuse them all the time? That's all. We just keep reusing our sockets. So we have a map of socket ID to a socket. Yeah, but we can't because these socket IDs will always be different. We're still gonna have to have a lock on the map, I think. Yeah. Okay, so here's what I'm thinking. Okay, let's get back to here. We set the socket ID to null, and then so that the socket's now closed, and then we unlock the mutex lock so that if somebody was trying to write on that socket, that's what this mutex is for the socket. It's really, you don't want the socket to be reading and writing at the same time. So you acquire the lock. If someone's trying to write, they're gonna stop. Once we unlock it, they go to write, they check, oh, the socket ID is null, so the socket was closed, so I'm just not going to do anything. This should be in send socket data. Right, when we send on socket data. Right, so once we receive information, we acquire the lock. Right. We acquire the lock, and then we go to on socket data. If it's a closed frame, we're going to send the data, right? And then we're going to unlock, right? And we're going to unlock the mutex. So then if someone's going to go to write it, they would check, oh, you can't write because it's like that. Now, who's going to check? Send a message should check, because this is where we're sending an actual string. And I already have that there. Okay, so we lock the mutex. So get the socket, lock, require the lock. Right, acquire the lock, and then we need to check if the socket's socket ID is null. Then that socket's already closed, so we're not going to send anything, right? That socket's already closed. Socket has already been closed. And so lock the mutex. If the socket ID is null, we're not going to do anything. That socket's been closed. So we should unlock the mutex lock, right? We're going to unlock it. And yeah, that should be it. We're going to unlock it, and then that's that, because we're not writing to it. Otherwise, we send that and then unlock. Now, on disconnect, so we acquire the lock on the callback, and then we call the callback on disconnect. If on disconnect tried to send socket data, that socket's already closed, so it's not going to do anything. Okay. Now, here's the thing. We break. We get out of this loop. This is where we create the socket thread. So what we need to do here, we set the thread on the socket, right? And then we do this. We're going off. I think what we'll do is I'm going to clean up resources whenever I get a new connection. So when the socket closes, the thread's still just going to be there until somebody else connects. When somebody else connects, right, when we accept a connection, before we do anything, before we even check if the socket is invalid or whatever, before we do anything, we're going to want to free up any threads that have been closed. We're going to want to close a thread. Okay, here's the thing. When I call join, if the thread is already terminated, what happens when I call join? That's the question I have. Where is the what's joinable? Checks if the thread object identifies an active thread of execution. Specifically, returns true if get ID is not equal to std thread ID. So a default constructed thread is not joinable. A thread that has finished executing code but has not yet been joined is still considered an active thread of execution and is therefore joinable. Okay. So before start, so this one, it's not joinable. This one is actually joinable. And then we've joined it. And so it's no longer joinable. Okay. Blocks the current thread until the thread identified by finishes its execution. The completion of the thread identified by this synchronizes with the corresponding successful return from join. Okay, that's okay. So what we do, accept the connection, and then what I want to do is I want to free free closed threads. I know everyone's going to want me to write a function to do this, but I don't think I'm going to have this in a function. We'll see. So we're going to go for... I think we should rename that the socket map. So we're going to go through all of the sockets, and then we're going to check. I don't care about the ID of the socket. I care about the socket itself. So this is the socket itself. And we'll do this. If the socket's ID is not null, then the socket's still running. It's good to go. It hasn't been closed yet. Nothing to do. If the socket's ID is null, this socket has already been closed. Now we have to be careful because here because this is where we set the socket ID to null, right? Let's say we close the socket and then right before we set the socket ID to null, we accept a new connection. It checks that socket and oh, nope, that socket is not null. And then we set it to null and we unlock, it would miss that. So what we want to do, I think, is I might be overthinking this, but I think we may need to lock on the sockets. This is we accept a connection for a new socket, and now I'm going to have to wait. If that socket's sending data or that socket's receiving data, I'm going to have to wait until that socket's done. That may still hold things up. I don't think I need to lock here. I think it's fine. If the socket's ID is null, that's great. We know no one's going to use it anymore because even if it acquires the lock, it will check, oh, the socket ID is null. It's not going to do anything. And we know that socket's no longer receiving information. If the socket ID is null, I mean, if the socket ID is null, that thread, that's here, right? If the socket ID is null, that thread has basically terminated, right? I mean, all that's left is we unlock the mutex lock, right? We unlock the mutex lock. In case the person writing to the socket is waiting. Unlock it so that now they'll see that socket ID is null. But then we do this, right? We have to wait for the lock on that. That's the thing. We could set the socket ID to null, then the accept comes in. Oh, the socket ID is null. It's going to wait for that thread to terminate, but that thread may not have terminated yet. We need to know that the thread is actually terminated. I don't want to have to join and then wait for this lock. I mean, again, these are edge cases. This isn't going to really matter. All these things are going to happen very, very fast, but it's just you accept a connection, and then we're going to be waiting to get the lock on the callback to say that we've disconnected. That should be a short thing. Then we unlock. Well, we could just have a flag that the thread is terminated. So if the socket's ID is null, that means we've closed the connection. Is there another way we could say that? If we've if we've closed the connection, we could set the socket to be done, right? So socket error, right? I'm curious, what is socket error? It's -1. Okay, so that's what we do. We say we don't set the socket to null, right? We say we set the socket ID, or no, we set the socket. We've already closed the socket, so we don't need to use the socket anymore. We close the socket. Okay, so the socket's mutex is really a lock on the socket so that you can only do one thing at a time. We can't close the socket while sending and whatnot. That's really what the mutex lock is. So once we've closed the socket, we can then set the socket to socket error. Right? We set the socket to socket error. What that means is that we've closed the socket. If the socket is set to -1, if the socket is set to, kind of weird to say socket error, but the socket is set to socket error, then that means we've closed the socket, right? Unlock, and that's what we're going to check. So in send message, that's what we're going to check. We're going to check if the socket, is socket error, then socket has already been closed. So we're checking the socket. So that means the socket's closed. Then we're going to do this. We're going to acquire the lock. We're going to do this. So it's not until here that we say, okay, socket ID is null. If the socket ID is null, that thread has terminated or is just about to terminate in like milliseconds. I know this, I'm going too far. I could have just done that here. This whole thing won't take a long time, but it's just that I'd be setting the socket ID to null, and then if the accept comes in, it's going to think, oh, the socket ID is null, so the thread is terminated. But it then may have to acquire the lock, do some stuff, and then wait a little bit. I don't want there to be a delay, so set the socket ID to null. Socket ID of null means that the thread has terminated. Yeah. We come in here. If the socket ID is null, that thread is terminated, or is basically about. There's no instruction left, so that thread is basically terminated. So if the Socket ID is null. The thread is terminated. So then we check, well, is the thread joinable? If maybe there may, for some reason, it may not be joinable. And if the socket's thread, socket thread joinable. If the thread is joinable, then we say socket thread dot socket thread join. This is a blocking call. Accept connection. Free closed socket threads. This is a blocking call, right? This is a blocking call. But by that point, if the socket ID is null, there should be nothing left to happen on that thread, and that thread should either have terminated or will terminate very quickly, very shortly. So it's okay that we block for a short period of time. We join the thread, and then we keep going. What else do we do when we join the thread? We join the thread. Once it's joined, we can then free the socket's thread from memory, right? And then we can actually free the socket itself, right? We can free that memory. Before we do that, I would say join. Once we've joined sockets, how do we remove? Yeah, how do we remove from a map? I'll actually do the removal. Is it erase at a particular position? Oh, you can erase by key, right? Okay. So sockets.erase. Well, the socket ID is null, so I don't know the key. Oh, that's actually a problem. Okay. Yeah. Oh, no, I know the key because I'm iterating over it, so kv.first is the key. So we join it. Once we've joined, that's a blocking call. We wait. Once we've joined, who calls sockets? I just want to be sure that it's only in this guy here. This guy adds people in there. Yeah. Yeah. Okay, I think we're good. So free close socket threads. So, yeah, erase it from the map, free the thread memory, and then free the socket itself, right? Yeah. Free the socket itself, and then we keep going. Do that for all that. And then what do we do? At the end we go over each socket. Just do this to make it so. Join if it's joinable, then join the thread, delete the thread, and then delete the socket itself from memory as well. So just clean up. I think this is going to work. I just have a bad feeling there's a lot of blocking conditions here. Especially since I'm just using the mutex directly like that. Well, let's see if it's actually doing the basics of what we expect. I can close Wireshark, don't need that now. No bugs, okay. Yeah. So, I'm gonna run it. We have a connection. Great. Now, if somebody else comes in, they connect. Great. Now, let's say this guy disconnects. Well, if I refresh, he's going to disconnect and then reconnect. So it comes in here. We have the socket. It's 1, right? And so we're going to join that guy, erase it, and then keep going. Oh, no, fuck. No. Okay. No, this is a problem because we're erasing from the map and we're iterating over the map. That's a problem. Sorry. Brief pause. Okay, back. Instead of doing this, we're gonna have to actually iterate over all of the keys. How do I do that? I think it's like key set or something like that. Yeah, I don't want to do. I can't do it that way. Come on, man. Look at this insanity. All I want to do is iterate over... I know for a fact, I'm pretty sure it can be done, just iterating over the keys. Look at this insanity. What the fuck are you doing? You really can't do it? I thought you could do this. Man, you really can't do that? 2023 and you can't iterate over a list of keys in C++. But hey, we've got auto. This is why I can't wait for Jai to come out. When Jai comes out, I don't think I'll ever do any C++ program anymore. I think it's just going to be Jai. I think I'm just going to go straight to Jai to avoid all of this other bullshit. I can just write code. I don't have to spend an hour on fucking Stack Overflow looking at how to iterate over a list of keys. Is there really no way? I thought I've done that before. Okay, so yeah. Okay. Oh, okay, right. We could, okay, I'm gonna trust that that works, which is a big... We'll return the iterator past the deleted element. Okay. Yeah. Okay. 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 Still insane that you can't get a list of keys from a map just like that. That blows my mind, but maybe that's just me. Okay. So sockets.begin, beginning of the list, and then we're gonna say while the iterator is not equal to sockets end. Maybe I'll have a, should I have a space there? I don't know what I normally do here. Oh, okay. So what we do here is we increment the iterator, but here we say the iterator is equal to sockets.erase. Actually, we don't have to do this now. We can just say the iterator, right? Right. So we increment the iterator. Here we just say sockets erase iterator, and then we get the new thing. So we need to change this. So this isn't KV now. This is. How do you get the actual value? I usually don't use iterators. What does that mean? Avoid the typical increment of it at the end of the loop. Right. He's saying don't put it there. And I'm assuming I can do plus iterator, and that should work as well. There's no good reason to have... We could do a video just on the comments on this page. There's no good reason to have a for loop that doesn't increment anything. This would probably be better as a while loop. Sure, but I mean, in a while loop, you didn't have to move this outside of the while loop. So you'd have the exact same code plus one line. So you just have longer code to do exactly the same thing. It's more concise just to put it there. I don't agree with this this whole idea that a for loop doesn't increment anything. Who made up a law that for loops have to increment something? Who made up that law? Michael Christophic. Okay, I don't use iterators usually, so yeah. I don't use iterators. It's actually a bit embarrassing, but I don't use iterators very often, so do I dereference the iterator? I believe that's what we do. I believe I dereference the iterator, and that gives me the thing that I'm pointing to. I believe that's how it is. Well, let's take a look. No. Okay. What does it have, iterator? Oh, to the... No. How do I get the actual... What? One dereference for the iterator. One for the pointer the iterator refers to. That doesn't make any sense to me. Okay, well, okay. What is this iterator? This is an iterator. Dereference it just like a pointer. Okay, I think this is what we'll do. Okay, so let's test that again now. We've gone off into the weeds here. Okay. And now if I do this, everything still works. Okay. Okay, so where we're at now, we can have multiple clients connect to the server. They can connect, disconnect, send data. We can send data back. That's all looking pretty good. In terms of the multi-threading stuff, there may be some deadlocks there that I'm not taking care of. There may be some issues. I'm not aware of them at the moment. I mean, but we're doing pretty good. I mean, we can connect multiple clients. They can connect, disconnect. They can send data. We can send data back to them. We're getting there. What's left, I think, is to clean up Fenrir, to clean up the library. Fix any multi-threading related issues. Make sure the callbacks are good. Clean up any of the callback things. Although I think everything's good to go with the callbacks. Yeah, we get connection. We get a disconnection message, right? Disconnected. Client. Socket connection established. So I think we're good in terms of that. What's left is some cleanup items. That will be the next video, going through cleaning up some stuff, making sure everything's working well. And then after that, what will be left is making sure this works on Linux. This is obviously working on Windows, but I need this to work on Linux as well because I'm going to run it ultimately on a server, and it's going to be a Linux server. So I need this to work in Windows and Linux. So that'll be not the next step, but the step after that. So we have at least 2 things left to do with this. And then the Fenrir library will be ready to then be used by what I'm going to do next, which is actually using it to replace my use of Node.js and Socket.io for a card game that I've already got working. Yes, so I think that's it for now. That's what we'll work on next time. Yes.